So this lesson master is lesson master 5.4, and it's all involving arc or inverse sine. So for inverse sine, let's go to our unit circle. Anytime we're talking about inverse sine, we're going from negative pi over 2 to pi over 2. So we're only going to look at the right side of the unit circle, and this is considered the positive quadrant, and this is considered the negative quadrant. So this is pi over 6, this is negative pi over 6. This is pi over 4, this is negative pi over 4. This is pi over 3, this is negative pi over 3. This is pi over 2, this is now negative pi over 2. So let's go to our questions, and again I'm going to do the same thing. I'm going to draw the section of the unit circle that we're going to use. We're only going to use this section, and all of these angles are positive, and all of these angles down here are going to be negative for inverse sine or arc sine. Okay. It says for 1 through 3, evaluate without a calculator and give an exact answer in radians. So we're going to use our unit circle. So we're asking ourselves inverse sine. So where is the sine square root of 3 over 2? So I go to my unit circle, and I only look at the right side because I'm doing inverse sine. And I look for the y coordinate to be square root of 3 over 2. And I see that that happens right up here. So my answer is pi over 3. Then it says arc sine negative 1. In other words, inverse sine of negative 1. Where is the sine or y coordinate negative 1? That's what it's asking for. So again, I go to only the right side of my circle, and I want a y coordinate that's negative 1. And I see that down here at the bottom. Y coordinate is negative 1, and that is at, it says 3 pi over 2, but I have to remember this is my negative quadrant, so this would be positive pi over 2, so down here is considered negative pi over 2. And lastly, well, this one says inverse cosine. I think it was supposed to say inverse sine, so I'm going to go ahead and change that to inverse sine of square root of 2 over 2. And the inverse sine there, that means I want the y coordinate. Where is the sine? Square root of 2 over 2. So look here. Y coordinate square root of 2 over 2 happens right here at pi over 4. Now it says in 4 through 6, approximate to the nearest hundredth. So I'm going to use a calculator of a degree. So I need to make sure that my calculator is in degrees, and it's not, so I need to switch it to degrees. And inverse sine of negative 0.55. So inverse sine negative 0.55, and I get negative 33.37. Negative 33.37 degrees, which makes sense. It's a negative sine, so it's going to be in the negative quadrant. So it's negative 33.37 degrees. All right, let's go to the next one. Inverse sine of 4/5. So inverse sine of 4/5. And I get 53.13 degrees. Lastly, I have arc sine, which remember means inverse sine of 0.678. Inverse sine 0.678. and I get 42.69. 42.69 degrees. Okay. For this next one, it says in 7 through 8, find x, where x is between negative pi over 2 and pi over 2. So it's telling me again on my unit circle, I'm going from here to here, and this is negative pi over 2. And at the top here would be pi over 2. So all my answers have to be in between here. Now this is radians and to the nearest hundredth, which means I'm going to use my calculator, but my calculator needs to be in radians. So I'm going to go to mode, switch it to radians, and then I'm ready to solve my equations. I'm trying to solve for x. I need to get rid of that 4, so I'm going to divide by 4. And I get that the sine of x equals 3/4. And I take the inverse sine of both sides. And let's see what I get. Inverse sine of 3/4 is 0.85. So I get 0.85. That's what x is going to be. Next one. All right, I gotta do a little bit more work here, it looks like. I need to, now, when you look at all this, don't say, oh, I don't know how to do it. Just start going one step at a time, trying to solve for x. This 1/4 on the outside I can get rid of by multiplying both sides by 4. So if I multiply this side by 4, I just get sine. That cancels those out. Sine of 1/2 pi x equals, I need to multiply this side by 4. So I have negative 0.25 times 4. I get negative 1. Now, I can't do anything with this until I get rid of this fourth side. So I'm going to take the inverse of each side. Here they cancel, and I'm left with, I can write it as 1/2 or 0.5 pi x equals, what is the inverse sine of negative 1? Let's see. Inverse sine, negative 1. Negative 1.57. Maybe I should write out the whole thing for now. Do my rounding at the end. The only thing I have left to do to solve for x is divide both sides by 0.5 pi. You've got to be real careful here when you divide by 0.5 pi. Divide by, I have to put it in parentheses, 0.5 pi. Otherwise, it'll divide by 1/2 and then multiply the whole thing by pi. We don't want it to do that. We want to divide by 1/2 pi. And I just get negative 1. So that's my final answer for number 8. Okay. All right, next. I'm going to look at the equation of the function and state its domain and range. All right, so for the inverse sine, you need to go back to that first page, inverse sine. My graph was right here, and my domain went from negative 1 to 1, and I have that written here. Domain is negative 1 to 1. X is less than or equal to 1, greater than or equal to negative 1. And then my range, let's look at my range, goes from negative pi over 2 to positive pi over 2, which is what I have written right down here at the bottom, negative pi over 2 to pi over 2. So y is less than or equal to pi over 2, greater than or equal to negative pi over 2. And then for number 10, almost the same thing, except I'm multiplying 3 times the whole thing. Just kind of like having a scale change where I've done nothing to the domain, the x value or the t value, but I've multiplied the y values by 3. Because of that, my domain doesn't change, so I leave it the same. But my range gets multiplied by 3. So 3 times negative pi over 2 is negative 3 pi over 2. And 3 times pi over 2 is 3 pi over 2. So you're going to be doing the 5.6 lesson master on inverse tangent on your own. But use what we've done here with inverse sine and on the previous 5.2 with inverse cosine. You have enough examples to help you to do this next one, 5.6, numbers 1